Okay, so today's notes are on relations and functions. We're starting out Unit 2. Our content objective is going to be to graph relations and identify functions. And our language objective, similarly, will be define terms such as relation, because we're going to graph them, and then function as well as domain, range, vertical line test, independent variable, and dependent variable. So there might be some other vocab words in there, but those are some of the most key terms that we'll talk about today in the notes. So go ahead and jot those down, but I'm going to jump right into some of the content for the notes today. So the first thing I want us to define is relation, because this is the broader category that we're going to be talking about. So relations are a set, in math, are a set of pairs of input and output values. So a set of pairs of input and output values. So there are several ways to represent relations. So in our 2-column notes, I'm taking up a very small space for the left column because this is going to be the bulk of our information. So one way that we can do, or that we can represent a relation, is through ordered pairs. So you probably have worked with those before, but those are written in the form x comma y in parentheses as such. So an example of this, of a relation, could be -3, 4, comma, 3, -1, comma, 4, -1. Again, these numbers could be really anything. I'm just choosing the set that was in your book. I'm also putting brackets around it because it is a listed set of ordered pairs, but this is one way you can write or represent a relation, is through sets of ordered pairs like this. Another way you could do this is through a mapping diagram. You may not have seen these before, I'm not sure, but they similarly have input and output, or x and y's. And I'm just going to list these vertically and then circle them, though you could box them, it really doesn't quite matter. It's just a grouping of input variables and then a grouping of output variables. So I'm using the same set of ordered pairs that I did for the same set of inputs and outputs that I did for the ordered pairs. So here you're just connecting the input to the output it belongs with. So here we have -3 and 4. So I'm going to draw an arrow from the input to the output. So -3 to 4. I also have 3 to -1. So I draw an arrow that way. And then I have 4 and -1. So I'm going to draw an arrow from 4 to 1 as well, and then from 4 to 3. So again, I'm just copying the same ordered pairs into a mapping diagram, which looks like that. The next one we're going to draw or talk about is a table of values. You have definitely seen this before as well, but this is your x and y, or your input and output, and you just list each number with its counterpart. So -3 and 4, 3 and -1, 4 and -1, and 4 and 3. So this is our table of values over here. The last one we're going to draw together is a graph. Sorry, I realized I cut that off. The last one we're going to do together is a graph. And this one, again, I'm going to do a sketch of this. Hopefully you would have graph paper or something a little bit neater to do this with, but we're going to make do. So I'm going to draw some dashes up here, label my axis. This is my y-axis. This is my x-axis. So I'm going to label them, try to space these as evenly as possible. Okay, so here is my graph, and I know this is 4 up here, and this is -1 down here. And my first one is -3, 4, so I go to -3 over here, and then 4, so -3, 4, it's right about there, so I plot that point. And then I'm going to go to +3, and -1. So that, sorry, I should have written that on this side. So that point would be right about there. And then I have +4 and -1, so that's right here. 4. So I have 2 points there and there. And then my last one is at 4, 3. So 3 is here, 4 is here. Plot that there. So this could also be a graph of a relation. So it's just plotting the points. In some instances, you'll see an actual function, which we'll talk about what that is in just a second. So it could be a whole curve, but at the very least, you can graph it with points or a line or what have you, but that is a fair way or a valid way to represent a relation. All right, so I'm going to turn the page and define some other key terms that we need to know today. So the first one on the back side that I will define is the domain. So this is commonly known as the, I'm going to again do a very small column over here, but this is the set of inputs, also called x-coordinates, of the ordered pairs for a relation. So the domain is the x values of a relation. I am guessing you've probably heard that word at least once before. If not, it's important to know it is a very common term that will be used frequently throughout math, the rest of your high school days at the very least. But the set of inputs for the domain, the range is going to be the y values or the set of outputs. So also called y coordinates or the y coordinates. Of the ordered pairs for a relation. Great. Last term we're going to define, very importantly, a function. So a function is a subset of relations. So a function is a relation in which each element of the domain corresponds or connects to or connects with exactly one element of the range. For me, it's helpful to make a sort of simplified definition for that. So a function is a relation where x values aren't repeated. So x values will not come up for more than once for a y value or for y values. So this is sort of the simplified way of for me to think of it. So x's can't repeat, x's can't come up twice. For every one x, there should be one y. So just to clarify the relationship between relations and functions, all functions are a subset of relations. So relations is the very big, broad category, and functions are a subset or a smaller group within that. So functions are all relations, not all relations are functions. Relations are the broader category. So the other part of our objective today is to identify what is a function and what is not a function in those different notations we talked about. So we're going to do a little table. And first thing we're going to do is a mapping. So we have our domain and range. And we're going to have -3, 0, and 4 in the domain. And we're going to have -2, 1, and 7 in the range. And if we're going to connect 3 to 1, 0 to 7, 4 to 1. But this is a function because look, each one of these x's only goes to one y. So there's only one x going. There's no two arrows coming out of an x. So there's not more than one value for an x. For our not a function, as you might be able to guess, we're going to have the opposite. So we have 2, 3, 4, 6 in our domain circle, and then we have -3, -1, 3, 6 in our range bubble. And 2 is going to go both to -3 and to +3. And that is not allowed. So this is why this is not a function, because this 2, so I'll circle this in a different color. 2 repeats it, or is the domain value for 2 different range values, so this will not work. The 4 is also going to 3 and to 6 to 6. But the key point here is since the 2 has 2 arrows coming out of it, it is not a function. All right, so we're getting towards the end of here. The same would be true if we saw a set of ordered pairs. So if we had, say, -7, 14, 9, 7, 14, 7, 7, 14. These are all fine because none of these x values repeat, so it's negatives and positives, not the same number, so that's fine. However, if we did have an ordered pair like 4, 1, 8, 6, 1, -1, I'm going to continue in here, 6, 6, and 4, 1. Sorry, 4, -1. Then we see the 4 repeats here and here, so it is not a function. The last thing I'm going to do is show us the graph and how we can tell with the graph that it's not a function. So one, we'll draw a function here. So if I had my x and y axes, say I had, we'll do an absolute value graph. Don't need to know this right yet, but this one you can see just going across that there is no x value repeating because we can do what's called a vertical line test. And I'm going to show you another graph so you can sort of compare the two and see what I'm doing. So here I have my x and y axes again, but in this case I'm going to do a sideways parabola. And so this one we're going to demonstrate another vocab word for today, a vertical line test. And this says that if a vertical line passes through more than one part on the graph, sorry, point on the graph. Point, sorry if you can't read that, that says point on the graph of a relation. And the relation is not a function. So what I'm talking about here is if we drew vertical lines and kept going and went through all of these, or kind of, I think of it as using my pen and doing a scan, and I see that at no point is my pen crossing the function or these arrows at the same time, then I know it passes my vertical line test. However, if I did it over here with this one, you see it passes through here and here. So that would fail my vertical line test. So I know it fails my vertical line test when it passes through more than one point on the graph, because that means that this x value corresponds to both of these y values, which we know is not a function. Still a relation, but not a function. All right, so that's all we're going to do for today. Make sure you write down any questions, comments, or concerns you have on these notes so we can go over them together in class.